I'm going to give you 5 minutes to have a go at this question and see how you do. One minute to go. Right, so let's go through this question. So when a ball is thrown, height above the ground is given by this. From what distance above the ground is the ball released? Well, the ball is released when t equals 0. So therefore, at t equals 0, s of 0 will equal 1.2 plus 0 minus 0, because t is 0. Anything times by 0 is 0. So it's just 1.2 meters. Part B, find s dash of t. So we're doing s dash of t. Differentiate this. That goes to nothing. 28.1 t goes to 28.1 minus 2 times 4.9, which is 9.8 t. What does this mean? Well, if that is height above the ground at any time, this is the rate of change of height. Or you might consider it to be speed. Okay, the rate of change of height. This could be the speed at which it's moving at any one moment in time. So, C, find t when s dash of t equals 0. So make that equal to 0, and we get 28.1 minus 9.8 t equals 0. So therefore, t will equal 28.1 divided by 9.8. Let's grab our calculator. To get t, divide to divide, I do 9.8 onto t onto this side, then divide by 9.8 is how I get that. Menu 1. So we get 28.9 divided by 9.8, and it is 28.1. My class is helping me put the right numbers in here. Can't read my own writing. And we get 2.86. So it gives us 2.87 to 3SF. And that's in seconds. What's the significance of this result? Well, this is the result where the rate of change of the height is 0. So it's either going to be a maximum or a minimum. Now, if we go back to my graph, we go menu 5, I've already drawn the graph. There we go, we can see it's going to be a maximum. So therefore, this is the point. So this is where the rate of change is 0, so the speed is equal to 0 at this point. So therefore, maximum height. Or the time when you have maximum height. So if we want to find the maximum height, let's just give ourselves a bit more space. D. So the maximum height reached by the ball is going to be when the time is this time here. And we need to put it into this equation. So let's go to our calculator and go menu 1. And we can just put that answer into the equation. So we go 1.2 plus 28.1 times by our answer minus 4.9 times by our answer squared. And we do this to make sure we don't have any rounding errors. And that gives us 41.48, so 41.5. So max height is equal to 41.5 meters. So is there a question in the class? You could also, if you draw on the calculator, I get used to doing both ways, okay? Because if you do a hence, then you have to do it the way they said, okay? So get used to doing it both ways. So we could also do the graph on the calculator, press graph, solve, go max, and it gives you the time it happens at, 2.867, and it gives you the y value as well. So you can just sketch on the calculator and it will work it out for you. So find the ball's speed when released. So we can put these values into the equation for the gradient. So E, so ball speed when it's released, t equals 0, so therefore speed equals 28.1 meters per second. Part 2. So s dashed of 2 will equal 28.1 minus 9.8 times 2. You can work that out on your calculator. I'm not going to do that now. And then for S dash to 5 for part 3, you can do 28.1 minus 9.8 times 5. Again, put that into your calculator. I'm not going to use video time op to do that. Right. State the significance of the sign of the derivatives for each of these values. Well, what you'll notice is this one will end up being positive. This one will be positive, and you'll find this one is negative because it's falling back down. Okay, so that means that that's the direction of the velocity. So it gives you the fact that it's falling back down in part 3. So first two are positive. Therefore, it's going up. Last one, negative. Therefore, going down. And then what was the last question? How long will it take for the ball to hit the ground? So we need to find when the equation equals 0. You've got lots of ways to do that. You could do it with the graph. You could do it with solving the equation. As I've got the graph drawn, what I'm going to do is I'm going to find where the roots are on the graph. And we get 1x equals 5.77, y equals 0. That's that one there. I've taken the domain to be such that the first one, when x is equal to 0, no, it's not going to be where it hits. That's the time above the ground. Oh yeah, the other one's going to be negative, so it won't actually exist. Okay, because it starts at 1.2, if we go back beyond the beginning of the axis, we end up with a negative time for the first one when it's there, when it's going to be equal to the ground. So it will take 5.77 seconds. So F, it takes 5.78 seconds. Okay, so two ways to do this. Solve this equation on your equation polynomials. You can go into menu alpha A, and you go to polynomial and put it into the degree 2 one and solve this, and you get two answers. One will be negative and one will be the one we found. Or as we saw, you can use the graph and find where the roots are because we're solving this equal to 0. Right. Our next question we are going to look at is this one, question 1 here. So I'm going to give you 5 minutes to think about this question and see what you come up with. 1 minute to go. Okay, so we've got to, first of all, differentiate this. Every time you see the word maximize, you're thinking differentiate. So let's differentiate this, and we get 2 times this was minus 0.044x plus 11. So then when you maximize this, we're going to have the derivative equal to 0. So 0 equals minus 0.044x plus 11. So x will equal 11 divided by 0.044. So you can do that on your calculator. Let's go menu 1, and you can do 11 divided by 0.044, and you get 250. 250 pounds. Okay. Oh, no, that's x. Sorry, 250 items at a time. Sorry, 250 items. So that's production level that will maximize profits. So effectively, we've answered the question. Now another way you can do it on your calculator. Again, if you use the graph, we could type in the graph here. So let's just delete all of this. I'm going to leave the x squared in there. Because I'm going to get minus 0.022 x squared. I haven't put the minus in, I'll put it in a minute. 11 x minus 720. Go back. Actually, quick way to go. Click on forwards. Put the negative in there. Press execute. Press draw. And we don't get it on the thing. So bear in mind, I've got 250. That's not a surprise, because if you go view window and you see my x value maximum is 10. Well, it's quite hard. Let's just say it's not easy to see, so let's just chuck in 500 as not my min. Let's go. We've got to have a minimum of 0, because no point going below 0. Let's just chuck in 500 as our max and see what happens here. And press draw, and we get part of our graph. Now, as long as we've got the x values incorporating it, I think if we do graph solve and go for the maximum, it will find it. There you go, it's found it. There's a dotted line there showing where the maximum will be, and the maximum is given as 250, the number of units, and the profit you'd get is 655. But it doesn't ask for that. But that's how you can use your calculator. We just wanted to make sure we could see it. That helps you. Sometimes it helps people to see it. Let's just make the y value 750. That'll definitely get it in. Press draw, and you can see the graph, and we can just do the graph solve again, get the maximum, and you can see it happening at maximum. It often helps people to see. So that's question 1. Let's have a go at question 2. Now, having seen that, I'm not going to give 5 minutes. Okay, let's just give you 3 this time round. Do it properly first using the differentiation, and then check your answer using the graph method. Right, we'll stop there. Whole class had a go at this question. So we're going to find h dashed of t. So the 1.6 goes to nothing, so you get 32 minus 9.8 t. And we want to find the maximum value of this, so therefore we're going to make that equal to 0. So let's do 32 minus 9.8 t. So t will equal 32 over 9.8. 32 divided by 9.8 gives us a time equal to 3.265 seconds. Now we want to find the maximum height, so we need to type that into our answer. Let's do 1.6 plus 32 times by our answer, so as we don't lose any values in rounding, minus 4.9 times by our answer squared, and we get 53.844, so that's 53.8 meters to 3 SF. Just to complete this, let's just have a look at if we use the graphical method using our graphical calculator. Let's just delete this equation and put our one in. So we got 1.6 plus 32x. We're going to use instead of t because it always uses x, minus 4.9x squared. Check the function. Yep, put that in right. Execute, draw, and it's gone a little squiggly thing down here because of our view window. So let's just use a standard to start off with, see what that gives us. And that gives us something like that. So let's do another change of view window. So we go from 0 to 10. Now we know, we're lucky because we've done all the maths. Oops, I meant to do view window again. Exit, shift view window. Right, let's go down and change our Y max to 60. And we'll be able to see it. Draw that, and we can now see it. And if we go to graph solve, max, it gives you the maximum value at 3.265, and the maximum value of Y is 53.844, and we can see it happen just there. So our graph agrees with our algebra, so that's all good news. I'm just going to miss out question 3 and jump, which I was planning to do, but in the time we've got, not make this too long a video, we're going to do this with 2 more complicated questions. So here's one to do, where some algebra has to be done first, and you have to do the differentiation, and you have to solve it using differentiation. So you can't just jump straight into your calculator, because you'll get no marks if you're doing this in the exam. So have a go at this. I'm going to give you 5 minutes, because this is a little bit more involved, and there's some hard algebra to start with. Tip for the top in the exam: if you can't do part A and part B, jump straight into part C. Okay, jump straight into part C and D and E, because those are doable without doing parts A and B. one more minute to have a go A, B, and C. I'll do them, and then you can finish off doing D, E, and F after that, if you haven't got those out. Okay, so let's go through A, B, and C to start with. Now, to explain this, you know that the inner surface area is 108. So all the inner sides of this, and it's an open rectangular box, so there's nothing on the top. All the area, the 5 faces inside, must add up to 108. So we know this side here, and this side here, and this side here, and this side here, all equal y times x. And that's 4 of them. So we've got the area equals 4 times y times x, and then we've got a base equal to x squared. So therefore 108 equals 4yx plus x squared. Part B, you want to get y on its own, so let's take away x from both sides. So you get 108 minus x squared equals 4yx, and then I'm going to divide by the 4x. So I'm going to get 108 minus x squared over 4x equals y. Now I want to find the formula for the capacity of the container, so that's the volume. Now the volume is equal to the height times the area of the base, and the area of the base is equal to x squared, and I'm going to times it by the height, which is y. So therefore C will equal whatever y is, which is all of that, 108 minus x squared over 4x, and I want to times that by the height, which is x, the base area, which is x squared. Now, to simplify that, which would be a good idea, especially what we're going to do in the next part, x goes into x squared x times. So we can cancel that out and cancel that out, because you've got the whole of the bottom times by x and the whole top times by x squared. So if we just multiply this out a little bit better, we get 108x minus x cubed all over 4. I had 4x and I had x squared. The question was, where did my x go to? I just cancelled that out with that, because that's equal to x times x. Cancel one of them out with the x on the bottom, and I'm left with this. So find dc by dx and finish off the rest of the question. I'll give you 2 minutes to have a go at that. So we want to find dc by dx. Well, first of all, I'm going to divide both these bits by 4. So I'll get c equals 27x minus a quarter x cubed. Differentiate this, dc by dx, and I get 27 minus 3 quarters x squared. So, and then ask me to find when that equals 0. So let's put, that was part C. Part D, I've got 0 equals 27 minus 3 quarters x squared. So 3 quarters x squared will equal 27. So x squared will equal, now if I times this, divide this by 3 quarters, the same as times it by 4 over 3. So I'm going to get 4 times 27 over 3. That will cancel to leave you 9, so it's 36. So x squared equals 36. So x must equal plus or minus the square root of 36, which equals plus 6 or minus 6. Now it can't be minus 6 because x must be a positive value. You can't have a negative length. So what size must the base be in order to maximize the capacity of the box? The base must be 6 centimeters. And let's just check that using our graphical calculator, doing it this way. So let's select it from there, go up, change the name of change my function, delete that one, and we're going to put in, what was it, 27x minus 0.75, same as 3 quarters. Oh no, not 3 quarters, 1 quarter, sorry. 1 quarter x cubed. And if we draw that, graph solve, find the max, we get x equals 6, and the maximum value of the volume will be 108 if we want to work that out. So that's how to do that question. Now, on all these questions, basically you have this idea of putting the information you've got in the question. So you've got the area is 108. Well, what is the area? Work out the area from the question and get that equation. And it's nice and kind that it asks you to rearrange it. And then you want to find capacity, which is volume. What does volume equal? Volume equals the bottom area times by the height. We've got the height, so times that by the bottom area, and so on. And then you always, if you can't do those bits, the problem with this question, normally they get you to do the show that on part C and give you part C so you can then differentiate that and get the rest of the question out. In this case, that wasn't so easy to do. In future questions, I'm sure that will be more likely. So let's have a look at this one, question 9. This is a tricky one. I'm going to give you 5 minutes to get started on it. You may not finish it in 5 minutes, and then we'll go through it. My advice to get most out of this video question is if you haven't got A and B out, jump to C now using the answer to A. Answer to B.
One minute to go.
Grab a pen. Okay, so part A. Explain why the height is given by this. So you're told the capacity equals 1 litre. So the capacity, the volume, equals 1 litre is 1000 cc. 1000 centimeters cubed. And we also know that the volume is equal to the height times by the area. So therefore it's equal to height times by pi r squared. So therefore h times pi r squared will equal 1000. And therefore h will equal 1000 divided by pi r squared. Part B. So the total surface area is given by this. We know that the top is equal to pi r squared, and we know the bottom is equal to pi r squared. So our area will equal 2 pi r squared. Better write down the pi r squared here and the pi r squared here. And then we've got the bit, the curved surface area. This is going to be h times 2 pi r. And the reason why it's going to be h times 2 pi r is because this length distance here, the circumference, is equal to 2 pi r. So that gives you, if you were to cut this and just make it into a rectangle, that length there, the top, would be 2 pi r, and this length here would be h. Okay, what would happen? So we got that this area is equal to h times 2 pi r. I need to put a plus there, not an equal sign. Sorry about that. We're adding these two together. So this is the two ends, and this is the curved bit round the middle. Now we know that h equals 1000 over pi r squared. So we get a is equal to 2 pi r squared plus h, which is 1000 over pi r squared times 2 pi r. Now the pi's will cancel, and we can cancel out one of the r's. So a will equal 2 pi r squared. 1000 times 2 equals 2000. And then we've got r squared and we've got an r here. So divide that by r leaves you 1. Divide that by r leaves you just r. And that gives us our answer that we're looking for. So we want to make a the smallest possible. So let's differentiate to find the minimum is what we're going to be looking for. So dA by dr, differentiate this, we get 4 pi r. The 2 and the pi act as a number. So we do power times by the power, so times this by 2. That gives me 4 pi. Take 1 off the power, leaves me just r to the 1, which is r. Now this is 2000 r to the minus 1. So times by the power, we get minus 1. Take 1 off the power is minus 2. So we get 2000 r to the minus 2. Now, that will equal max or min when dA by dr is 0. So we write that out. I'm going to write this as a fraction to make the algebra a little bit easier going forward. So this is the same as over r squared. So what I do next is I times throughout by r squared. I get 0. 0 times r squared is 0. Times this by r squared, I get 4 pi r cubed. Times this by r squared, I get 2000. Go down a little bit more. So I'm going to get 2000 equals 4 pi r cubed. So I can divide by 4. So 420 goes 5. So I get 500 over pi will equal r cubed. And this is where I'm going to start using my calculator. Go to menu 1. And I'm going to do 500 divided by pi. Get that answer. And then I'm going to cube root. So shift. Put that. Just shift that. No. Just shift that. There we go. So we can put the cube root in, and then we put the answer in. There we go. In there. Shift there. And I get 5.41. 5419. So it's going to equal to 5.42 centimeters to 3SF. So that's the radius that makes it as small as possible. So we now want to find out what h is. And h equals 1000 divided by pi times that. So let's squared. So let's just square that answer. Times by pi to get pi r squared. And I do 1000 divided by that answer. And that gives me 10.83 for my height. So it's 10.8 centimeters to 3S. Now, to check that it's a minimum, there's a method called, there's two ways to do it. You can either do a sine table, or we can take the second derivative. I'm going to differentiate this again because it's easy to do. So d2a by dr squared is equal to, differentiate this again, I get 4 pi. Differentiate this again, I'm going to times by minus 2, so it's going to give me plus 4,000. Take off 1 off the power gives me r minus 3. Now, to check if it's a maximum minimum, let's put this 5.4 in. So 5.4 to the power of 3 is going to be a large positive number. Minus 3 is a small positive number. Times this by a small positive number will give me a positive number. Add it to this gives me a positive number. So therefore, d2a, so at r equals 5.42, d2a by dr squared is greater than 0. Therefore, we have a minimum turning point or value. Okay. If d2a by dr squared was less than 0, then we'd have a maximum. Right, now, the easy way of doing it, let's use our graphical calculator. So our function that we got from part B was this one here. A equals 2 pi r squared plus 2000 over r. So let's put that into our calculators. I'm just going to delete all of this. And I'm going to get 2 times shift pi times x squared plus 2000. And I could just do divided by x. It's the same, 2000 divided by x. Let's execute and press draw and see what happens. And we don't see very much. Now, which I'm surprised at, but we got 5.4 here, is about here. Maybe our y values are wrong. So let's go to just view window. Let's just do something standard and let's see what happens there. Press draw. And then we've got something happening. So if I want to do graph solve and do min, we get a minimum value of 5.4 at y equals 553. Okay. So if we go to view window again and then change our y value to not 1,000, probably a bit much. Let's go 600 and draw it. We'll see more. There's that minimum value there. Okay, worth zooming out just a bit, I think. I'm going to go in because for some strange reason my calculator does the opposite to what I say. You can see there's some funny things going on with the graph, and the minimum value is there. So just again, do graph solve, look for the min, and it finds that minimum turning point just there, and it agrees with our answer for R. And obviously H, you've got to put back into the equation to find H, to find the dimension that will make A as small as possible. And if you want to find the value of A, put the value of R into the value of A, or just read off this Y value here in the graph. Okay, that will do on this question for today, and that pretty much covers this topic.